my name is Jason Moeller, and today we're going to be talking about light. I would like to start this live science show with a bit of a simple game. Here on the table in front of me, I have 7 spheres. What I'd like you to do right now is take a look at those spheres, and I want you to think what color is each one of these spheres. Take a second to do that now. Do you have your guesses? Great. What I'm going to do is flip on our main lights and let's see just how close or how off you were. Ready? 3, 2, 1, and the lights should be on now. And how close were you? If these were very different from what you thought, don't worry. Here in our Eureka Theater, we have a couple of very special lights that allow us to block most of the light that's actually getting from the sphere to your eyes. In fact, the only lights you can really easily see are reds, oranges, and yellows, which is why those may have appeared a little bit easier to tell than the others. But what is light? Light is made up of small, tiny, fast-moving particles called photons. Photons can make up either light or other kinds of electromagnetic radiation, such as X-rays. Usually, when we think of light, we think of this coming from the sun. But the neat thing with light is that there are lots of things in nature other than stars that can actually play around with this radiation too. And we're going to look at some of those things today in our live science show. I'd like to start with one of my favorite little animals, which are scorpions. Scorpions, as you may see from looking up on the internet, can actually glow in the dark. And the reason that they're able to actually do it is quite simple. Scorpions during the daytime live in the desert and absorb a fair amount of heat. They need a way of getting rid of that heat so they don't accidentally cook themselves, and they do it in a really neat way. They convert that heat into photons, and they actually give it off as a special type of light. Now, I don't have any scorpions with me today, but I do have something else that should be able to do the trick and show this quite nicely how this works. This is a black light. For those of you who've ever been to an ice or roller rink before, these are the kinds of lights that they use to make your shirts glow in the dark. And it's not just shirts that can glow in the dark, lots of other things can too. We're going to go ahead and flip off on the black light and flip off our main light so that we can go ahead and see this a little bit easier. And you may notice that something quite interesting has happened to the water right here in front. When I put it over the black light, it goes a bright, vibrant blue. When I pull it away, it becomes dark again, but the moment I bring it back to the black light, it glows a bright blue. This is tonic water, and in the tonic water is something called quinine. Quinine does the exact same thing that the scorpion does. When it goes ahead and absorbs the light, in this case the light from our black light, it actually gives it off and fluoresces as a different kind of light. So fluorescing is one way that organisms in nature can go ahead and give off light. But it's not the only way. In fact, there's another very well-known animal in our area that can do this quite nicely as well. Can you think of the animal that's quite good at this? And if you said fireflies, you're absolutely right. Fireflies, though, don't fluoresce. Fireflies use a chemical reaction to go ahead and do this. Now, I don't have the exact firefly chemicals here, but I do have a couple of chemicals that should simulate the reaction quite nicely. In our first, we have what is called an energetic light solution, which is going to be what actually helps make our light for us. And then in here, we have what is called potassium ferrocyanide, which will chemically react with our energetic light solution to go ahead and, if I do this right, make light. And here, there's also a catalyst, an enzyme called hydrogen peroxide, which will help speed our reaction up. Once again, I'm going to go ahead and manipulate our light so that we're able to see this nicely, but still see it for its full effect, and then we'll do our experiment. So if you'll pay attention to the beaker right here, I'm going to do exactly what the firefly does in its abdomen. Okay? It's going to go ahead and mix these two chemicals together rather quickly, and you should be able to see the reaction. 3, 2, 1. And as you notice, it immediately goes ahead and reacts and produces light. The really neat thing about a firefly reaction is not just that it produces light, it's that it produces light without also producing a different kind of energy, which is heat. Again, just like our scorpion in the desert, the firefly doesn't really want to cook itself with its own chemical reaction, and so it's come up with a chemical reaction that actually gives off all of this energy as light and doesn't give this off at heat. Now, we human beings are also quite good at producing light. We're just not quite as good at producing it without producing the heat. The main way that we produce light, especially in our own homes, is through something called electricity. You may have seen a sphere like this if you've ever been to the Science Center. I'm going to go ahead and turn it on so that you can see it more clearly. This is what is called a plasma globe. The neat thing with plasma is that it is light that is actually, in this case, created by our electricity. Plasma is really just a gas. It's a gas that's had extra electrons stripped away from it, which we call ions. In this case, in the middle of our plasma globe, we have an electrical device called a Tesla coil that is producing a fair amount of electrons and moving electrons through that gas. This ionizes the gas for us and allows the plasma globe to go ahead and immediately light up. Okay? If I take my hands, and most of us who have been to the Science Center have done this, and I place it on it, my hands are actually a different charge from the Tesla coil, so the plasma appears to go ahead and jump right to my hands. Now, we use electricity to create light for more than just making fun little plasma globes. We use it for things like the lights in our home. The neat part, though, about light and electricity, though, is you don't just need electricity to turn it into light. If you do things right, you can also use light to actually create electricity. And that's what our final experiment here is going to do. If you look right here, and I will turn on the light for this first section. If you look right here, I have a couple of things on the table. The first is I have what appears to be a windmill. This, though, is going to be a solar windmill because it is attached to a fun little device called a solar panel. What solar panels are able to do is quickly catch these fast-moving particles of light, again they're called photons, and then are able to convert them into electrical energy that we can go ahead and use. Now you do need a fair amount of light for this, so I have today with me a very special, very large, very bright light bulb. Okay. What I'm going to do is I'm going to take my solar panel and I'm going to place it in front of this light bulb. During this experiment, please make sure that you are looking at the windmill and not at the light bulb because this light bulb is quite bright. I'm going to place the solar panel right here in front of the light bulb and I'm going to go ahead and turn it on. The moment I turn it on, the photons are going to go from the light bulb into the solar panel. The solar panel will be able to capture those photons and then we'll convert them into electrical energy, which we will be able to nicely see with our fan. Go ahead and watch the fan. Are you ready? In 3, 2, 1. And what is the fan doing? You'll notice it's spinning quite quickly. This is because the energy in the photons is being used to actually spin our fan. The moment that I turn this off, though, watch what happens to the fan. So 3, 2, 1. And you'll notice the moment that the photons are gone, the electricity also stops being made and our fan shuts off. This is how our solar panels work so that we can use these to actually provide and make some of our own electricity even here at the Science Center. Ladies and gentlemen, thank you very much. I hope you enjoyed that live science. Until next time, stay safe.